Hello everyone and welcome to Indy team demo. So we're about to finish our 19.10 sprint, and let us briefly go through the latest sprint. On the Indy node side, the sprint was devoted to transaction author agreement mostly. So we completed this epic. We supported GET requests for transaction author agreement. We supported validation of requests according to these rules and design that we presented during our previous demos. Also, this sprint, we started preparing to the next release that will be ready by the end of the month. And in particular, we extended our load script to continue the bug and validation. So this is the main thing that we did on the node side. On the token plugins side, the main goal was to integrate not out rules into token plugins. So this is also the work that we presented during previous demos. It's about configurable out rules and setting fees via this mechanism. So it was completed and covered by tests on plugin side. And also we continue this debug, validation, and integration in the load script for the next release. The new release of plugins is also planned by the end of the month. On SDK side, the sprint is also devoted to transaction author agreement and changes in setting getting fees and configurable out rules. So that's what was done, and we believe completed integration between Indy node and libindy. And on token plugins as well, it was supported to transaction author agreement for payment transactions and so on. So as a summary, two main tasks that we did as a team is transaction author agreement and configurable out rules with the new approach to set fees. And by the end of the month, we are going to create a new stable release with these new functionalities. As for today's sprint demos, it will be quite unusual demos because we are not going to discuss any particular issues or tickets, but rather we would like to show an end-to-end demo of what we did this sprint and previous sprints. It includes working with transaction author agreement from the user perspective, so how it will affect the user requests, API, and so on. And also, we are going to show full demo, full workflow, how to use tokens. The demo will be split into two parts. So first of all, the CLI, the command line interface, will be used for this demo, and the demo will be split into two parts. The first part is mostly for network administrators, for Indy full administrators, and it includes the how to guide, how to set out rules, how to set fees, how to set transaction author agreement, and if you talk about tokens, how to do minting, initial minting. And the second part of the demo will be devoted to end user workflow, and in particular, we are going to discuss how to send the payment transfer transaction and how other domain-related transactions, client name, schema, name, are going to be changed once fees are applied for a pool. So after minting is done, using out rules and set fees command, it is possible to set fees for some of the actions. So we're going to change how it may affect the workflow. So Sergey?
Thank you, Alex. Hello, everyone, and let me share my screen. As already mentioned by Alex, I'm going to show two parts of CLI demo. The first one will be more like from network administrator or from developer point of view who would like to create a setup very similar to Sovrin networks. So I'm going to start CLI and I can use configuration file for it. In this configuration file, I can specify a logger configuration, type of acceptance mechanism related to transaction offer agreement, and use a plugin for payments, which will be used while CLI running. So I'm going to use Evernym Token for this demo and click agreement as a mechanism to accept transaction offer agreement. So I start CLI and let me prepare some wallets, some keys, DIDs, payment addresses, etc. So first I would like to create a wallet, create configuration to connect to my own pool set up on my developer machine. And let me open wallet and connect to my local pool. And now I'm going to create some DIDs in my wallet. Firstly, it's default trusted DID for developer ledger of Indy. And also I would like to have more trusted DIDs because some of transaction for today's demo requires multi-signature. So I have to use different trustees. Okay, now I have some entities in my wallet. First one is known for ledger, and I can use it for future transactions. But others exist only in my wallet, and I'm going to publish it to the ledger and use it there later for other transactions. And I also would like to create some predefined DID for identity owner, just user without any special roles to show how house rules works, how to pay fees for some actions, etc. Okay, now my entities are published to the ledger. And actually, we just finished outside setup. And let's move to more interesting part of our demo. Previously, we had like separate logic for validation of rules on the ledger, who can write to the ledger and how. Now we there was fees mechanism. The fee can be assigned to transaction by type. But now we have more flexible approach. We have house rules, which was shown in details while previous demo. And we have aliases for fees, which can be used in house rules. So firstly, I have to set up some aliases. I would like to create alias for an action new schema, creating new schema on the ledger from identity owner, and I would like to create alias for transferring token, and I suppose that alias will be used for all roles, for example. So these transactions set fees requires multi-signature in default setup. So I'm going to use my trustees DIDs one by one and multi-sign this transaction. In this demo, I'm going to do it from one wallet. Of course, in real example, it will be separate wallets from different trustees, and they can use additional API to share a partially signed transaction from one person to the next one. I already used in CLI the first trustee, so I can just multi-sign at first portion of multi-signature for this transaction. Yes, I would like to do it. And now I'm going to switch to others. The second one trustee, one more signature, the third trustee, and the latest signature. Now we have a request which will post some new aliases to the ledger. In fact, it introduces just two aliases for our demo, it will be enough. And this request already has three signatures from 3 different trustees, as you can see at the end of this request. So now I'm going to post this transaction to the ledger. It's successfully applied to ledger, and now we can double check that this set fees command was successful, and I'm going to send get fee request to the ledger. And now we can see that we have 2 aliases in the ledger to apply fees for, via auth rules. Let's configure auth rules. I would like to choose 2 different actions. One of them is creation of schema, and the second one of transferring token from one payment address to another one. So let's see how appropriate auth rules looks by default. By default, to transfer tokens from address to a different one, you didn't have any distinction, and there is no fee by default. You can see that metadata field now is just empty object. And for creating schema, we have a bit more complex constraint. You can see three patterns and or operate around them. So by default, schema can be posted to the ledger by trustee, steward, or trust anchor, or inducer in new terminology. And I'm going to add new rule to allow just a regular identity owner to be able to post new schema, but it will be allowed only in case then identity owner will pay some fee. So I have prepared comment for that. And now you can see that we have four distinctions, 4 cases who can write to the ledger with new schema. And the new one is this part. So user without any special role can send new schema to the ledger, but he have to set some fees, and these fees are defined by this alias. And as you remember, this alias equals to fine. And I'm going to do a similar update for XOR transaction, but just to set up some fee per each XOR. And again, to double check, let's fetch these rules from the ledger. It's the response for schema and the response for XOR. And you can see that to XOR, transfer tokens from one address to another, you have to pay some fee. That's it about new auth rule, new aliases, and new fee policy. So it's very flexible approach. You can have a lot of complex constraints. They can be combined by or by AND operates, and can have nested conditions. So it's very flexible. And now I'm about to. I would like to mint some token to show demo from user point of view. So to mint tokens, I also have to use multi-signature. So I start and prepare a mint request. Then I have to multi-sign it from 3 trustee. Again, first signature from the first trustee, second trustee, second signature, third trustee, and third signature. And again, I would like to remind that in this demo, these 3 actions are shown from one single wallet, But in a real use case, you have to transfer intermediate results, intermediate transaction with partial signatures from one trustee to another. And CLI also have some headers for that purpose. You can save current active transaction to file. Test file is mint. And this file will appear in the working directory of the CLI or a new current directory. And you can see that in our case, it contains already 3 signatures. So if you would like to add one more signature from different trustee, from different wallet, you can email, for example, this JSON, then open CLI on another side, and then load this transaction from the file. And then let's send this mint transaction to the ledger. Okay, it's successfully sent. And let's double check that some tokens appears on the specific payment address. Here's our payment address, which will be used by in the second part of the demo. And here's some metrics that specify that this address for now has 100 tokens on it. And the latest part of the demo from user administrator point of view is about setup transaction offer agreement logic. There are 2 transactions for transaction offer agreement. The first one is for TA itself, and the second one is about how a user application will accept this TA. It may be some EOLI, it may be some click agreement or special steps by application. And there is the transaction about appropriate acceptable ways to do the acceptance is set up acceptance mechanism list. This transaction should be sent firstly because there is a required check. It's successfully posted to the ledger. And before posting transactional agreement text itself, some acceptance mechanism list should be present on the ledger. So transactional agreement is successfully posted to the ledger, and CLI asks me as a user of CLI, would I like to use this transactional agreement in my future write transaction? I can agree on it. That's it from a network administrator point of view. Let me switch wallet to imagine the situation that I now just as a regular user. And let's talk about the second part of our demo. So I'm also going to create a wallet to create some DIDs in it. And let's imagine that I own, in this case, 2 DIDs. The first one has role trustee, the second one doesn't have any roles, just regular identity owner. And I also have 2 payment addresses. So let me use first trusted DID for example, and I'm going to show that schema can be written by this trustee according to our rules without any fees. So you can see that it's successfully written, new schema on the ledger. And let me switch to the regular user and try to do a similar thing from his DID. And now you can see the error that I have not enough trusted signatures or not enough fee in my transaction. So I'm going to use, I have to use fees to be able to write new schema from regular user. And as soon as I soon as you can saw in our previous steps, the fee from new schema was 5 token. So let me post it. And now you can see a complex reply. The first part of this reply is about successfully posted schema. And the second one of reply is new UTXO attached to a similar address. It means that from 100 tokens, I spent 5 tokens for the fee or for new schema write request. And now I have less tokens on my payment address. And the final small steps from user point of view is transferring token from one address to another one. So let's double check that we actually have tokens on our address and try to send tokens from this one, from our UTXO attached to our payment address to another payment address. So I'm going to keep some token on my address. Let me copy it. So, and transfer 50 tokens to another payment address. It's successfully posted to the ledger. And you can see that we have 50 tokens on new payment address, and the rest of our tokens come back as a change to our own payment address. And let's double check it from by read request by get payment address sources. Yes, it's correct. So we have tokens on different payment addresses. First portion of the original one payment address and the second portion on new one. That's it from CLI point of view, from user used by a regular user. And I would like to mention that CLI for each write request, including payment transferring token, just append information about transaction offer agreement to each request. This appending performed automatically while CLI session. So if I disconnect from the wallet, from the pool, I will lose this automatic update. And on next connection, I would be asked about there is transactional agreement on this network which would you connect to. Would you like to read it? Yes, I would like to read it. And here I can see the version of the transactional agreement and text of it. And now I'm asked about would I like to accept it or not. I would like to accept it. And now while each transaction posted to the ledger, transaction of the agreement metadata will be appended to each request. It will include hash of content and version and time. Then I was accepted it in CLI in this case. It will be done automatically in CLI, but in real application, you have to add additional steps between building transaction and signing it and sending it to the ledger. That's it from my side for today. Thank you.
Thank you, Sergey. Thank you for the great demo. Does anyone have any questions? Okay, in case you would like to know more about transaction auth agreement or about new auth rules or about setting fees, feel free to learn our documentation in docs folder in Indy node and in Sovrin Foundation foundations repositories. It has some examples and description of these new commands. So we have a couple of minutes, and let me briefly show our next plans for the next sprint. So for both teams, the main task for the next sprint is to release Indy node and Indy together with Lipsov token and token plugins. So this will be a May release. And after this, we're going to start working on the June release. For Indy node team, this release is going to contain some improvements, stability fixes, and also we're going to start working on a pluggable request handlers. So this is architecture improvements, which can simplify the code and interaction, particularly between Indy node and token plugins. You see some tests for 1.0 or 1.9.0 already in the next sprint. And from the plugins point of view, we're going also to do some improvements, minor improvements, and also start working on this new pluggable request handlers approach for token plugins. From SDK point of view, also the main priority is release and also some fixes and improvements together with the release of Lipsov token or Lipsov token. Okay, so that's it. If no questions, then thank you everyone, and see you in 2 weeks on our next demo call. Bye.